So we try to understand in this topic what are the different kinds of misconceptions or the concepts which make us confused. Here the misconception part is identification of the languages. Majority of the candidates, they try to identify the language on trial and error basis. In a trial and error basis, what actually people will do here, taking the few sample strings of the given options and comparing with the machine what they're given. So whenever you take randomly one particular string and comparing with the language of the machine, it may be matched some cases may not be matches. Whenever you are taking a liberty to take this particular option as a trial and error basis, sometimes you may be successful, may not be successful. That's why my kind suggestion for all of you here, take time and list it out members of a given language starting from very first string to till 5 strings, you write perfectly. Same job you do with the options also. Take the job of each option, write down all members of the string starting from very first string. I am talking here very first string. Start your writing of the first member of a language up to 5 to 6 samples. If you do it for each and every option, you can find exactly one option will match exactly with the given language set. That is the right answer. This is the practice you have to do it. List out given language members with the 4 to 5 samples. Use the options and do the same job for each and every option. List out each option with the first string 2 till 4 to 5 strings. Then you can identify easily what set will exactly match with here the given language. So this is the way you have to do it, but never try like a trial and error basis. Taking one sample string from the given option and verifying with the given language, yeah, it may be matched some cases. But it is possible only because of the given language may be either superset of the actual language, maybe the subset of the actual language. If there is some kind of association, definitely you will all feel that yes, this is also going to be the right answer. But not the either subset answer or superset answer. You have to consider here exact answer. If that's wanted to be happen means you have to work patiently on identification of the languages with the samples. 5 samples you should work out. So that's the one point I suggest you here. So the first thing is what here? Misconception part. Right? Use 4 or 5 samples. Sample strings. So this is what you have to do here. Okay. Then other point what I am suggesting here, DFA and NFA have their more similarities. Only difference is what here in terms of delta. In case of NFA, you make delta as q cross sigma gives 2 power q, whereas in case of DFA, my delta can give here q cross sigma gives here exactly q. So that's the difference. Now what is the conclusion you can say here? Your NFA can have here one or more, but DFA can have exactly one. Indirectly you can say that every DFA is also kind of NFA, but every NFA is not necessarily be a DFA, but every DFA also can be a kind of NFA. That you can make it here. Another thing what I told you regarding the dead state. This is also called trap state here. we also call dead state or trap state. What is the dead state or trap state? Usually this is by default non-final state. Non-final state. Second thing is all inputs are self-loop for it. All inputs are self-loop. Another important thing you have to understand, this is always a reachable state. Reachable state. Once it is reachable, once you reached over there, then again you cannot back to the any other place. So they are the characteristics you can find for the dead state here. I think in our previous problems also you come across here many times the dead state situation. Of course, though we are going to discuss about the dead state details in the next video in detail. Right now you should identify these are the features of the dead state. Then other thing you have to look into this one. Sometimes partially completed machines will be given to us. Partial finite automata. You will be having about the language. For that language, you need to have a finite automata. It can be NFA or DFA. But the finite automata will be off constructed. Rest of the off you have to be constructed. So that is the one more model you have to focus for the examination. One is identification of the language. Otherwise, identification of the finite automata for the given language. Sometimes what happened, off a construction machine will be given to us, then you have to work on identification of the rest of the off connections. That is the one more model you have to look for the examination also. Then similarly, if you look at another points, what you have to remember for exam. Whenever you have a DFA, DFA will have here always single path for any W. Right? The point is here, DFA always have single path. Have a single path. For any W, you give any W, it may be have the single path. Whereas your NFA always have a multiple paths. Multiple paths for any W. But out of multiple paths, at least one path should terminate at final state. So now we are talking here one point, at least one path must terminate at final state. Then we consider W is accepted. Then we'll say then W accepts by finite automata or accepts by NFA. So this is what the definition, you can find it out here. Then how do you identify? See, if we take a table, NFA table can have a multiple entries, but DFA table can have your single entries. That's the one thing. So DFA table will have a single entities. Will have a single entities. Whereas NFA can have here multiple entities. NFA table can have multiple entities. That's it. So they are the essential points you have to remember after end of this particular topic.